Hi everyone. So in this video we are going to see how we can implement a stack using a single queue in Java programming language. Before going to implementation, let's see how basic stack and queue works. So let's visualize stack and queue. It's just a box, and we are trying to insert each integer in that box. So first we are trying to insert 1. So it will be there in the bottom of the box. Then we are going to insert 2. It will pile up on top of 1. Then we are going to insert 3. It will pile up on top of 3. So this follows last in first out concept or first in last out concept. Philo or LIFO we used to say. So this is push operation. Then for pop operation, we will pop the top element. So first we will pop 3, which is the last inserted element. Then we will pop 2. Then we will pop the first element that has been inserted to stack. So this follows last in first out concept while popping. Then we have a different data structure called queue, which follows first in first out operation. So first in first out operation, let's see the push operation how it works. Initially we are inserting 1. After that we are inserting 2. So 2 will be queued after 1 and we are inserting 3. 3 will be queued after 2. Let's imagine this like a person. Person 1 he is standing in a line, then person 2 is standing in front of 1 and person 3 is standing in front of 2. So whenever the person 1, let's say he has got a ticket, then he will move, right? In a similar way this works like first in first out. Whatever we have inserted first, that will pop out first. Then again 2 will come out, then 3 will come out. So this is how queue operation works. Let's see the implementation using Java programming language. So now I have a main class in my IntelliJ IDE. Let's define the main function, and let's create a static inner class. Static class stack. So let's create a queue of integer. Let's name as queue, and we create a new linked list. Actually, linked list implements queue. That's why we can create a new linked list for creating a queue. So we have created a queue now. Then we have push operation, right? Let's keep the return type as void for push operation, and the argument we are giving as a. That's it. So we can check the size of the queue by queue.size. Then we can insert that element in queue using queue.add. Okay, we have inserted element. Now we are writing a for loop. I will explain this for loop later why we are writing. S dot size. S is already a size. S then I plus plus. Q dot add Q dot remove. So what it does is it will try to rotate the elements in the queue. This for loop will try to rotate the elements in the queue. Let's imagine like initially we are pushing element 1. So the queue size will be 0 initially, and we are adding 1 now. So the queue size becomes 1 now. Then what we are trying to do, we are trying to iterate through the loop. Now I is equal to 0, I less than s. I less than s is it true? So initially the queue is 0, uh, and hence it won't execute this for loop. And currently we have 1 in that queue. Again we are inserting 2 in that queue. So let's see. Uh, Now the size of the queue becomes 1 since we have already inserted 1 in previous iteration. Then we are adding 2 now. And now since the size is 1, so the iteration will happen only one time because I is 0 and I less than 1 means only one time it will happen. So what we are trying to do here, we are trying to remove it. While removing, what will happen? The previous element will be removed now. So we have inserted 1 and we have inserted 2, right? So what will happen? it will remove the previous element 1 and it will add in the queue now. So queue already has uh, 1 and 2. So we are removing 1 now and adding it in the first place. So let's try to visualize it. So initially the queue will have 1 and it will have 2. So after for loop what will happen is we will try to remove this 1 and we will try to add it again. So the adding and removal will happening in the same place. So it's just rotated now. This rotation why we are doing, because we have to implement a stack. We shouldn't implement a queue. That's why we are rotating the elements in the queue. That's it. So this is how push operation works. Let's see the pop operation now. For pop operation, it's also a void, and we have to check if it is empty or not, if the queue is empty or not. We have this empty function to check it. Fine. If it is empty, I'm just returning it. Or else what I'm trying to do, I'm trying to remove it from the queue. That's it. This is pop operation. Fine. Now I'm going to see the top operation. For top operation, let's give the return type as int, and let's keep that name of the method as top. And again, if we have to check if the queue is empty, the queue is empty, I am returning as -1, or else I am trying to peek that element. Peek will just get the element without removing it. That's it. So I'm returning it. Fine. Now what I'm trying to do, I'm trying to get the size. In size, I'm naming it, and return q dot size. This will return the size of the queue. That's it. Okay, fine. We don't need this directly. We can get it from the queue. But anyways, yeah. Let's use that function since we have defined it. So let's create a object for stack now. I'm naming that as stack, which is equal to new stack initialized. Created a new object for stack. Then I'm trying to push each integer under that stack. First I am pushing 1, then I am pushing 2, then I am pushing 3, then I am pushing 3. That's it. So now I am trying to print the size of the stack. Size of the stack is, I'm going to print like stack dot size. That's it. Then I'm trying to get the top element. System dot how dot println top element is stack dot top. This will give us the top element. Then I'm trying to pop the top element. And again, after popping it up, I'm trying to print it. Top element after popping is, let's see the top element now. That's it, I guess. Let's run the code. So initially the size of the stack is 3, the top element is 3, top element after popping is 2. Let me see whether we can print the stack. System dot out dot println That's it. So it's trying to print the reference of it. So yeah, guys, this is how we can implement stack using Vue. That's it. Thank you.